All right. So I've handed back the chapter 3 packets to those who are here. If you're watching the recording and you're not here, come by my office or I'll keep bringing them and hopefully you show up because I don't want to carry them around forever. Chapter 2 packets as well. I've also got the math packet finally graded. If you didn't get a grade or I put in a 0, that means I don't have it. Or if for some of them, like the chapter 3 packet, I have the deadline as today and I put missing if I didn't have it. So if that's the case for you, then make sure to get that to me as soon as possible. Homework 3, the algorithm analysis one, that's due today at midnight. You can turn that in on Canvas if you'd like, or give it to me now-ish and I'll take it. And I want to remind you that the video is due next Thursday. So make sure you're meeting with your group, getting things going. It's due next Thursday. Don't procrastinate on this. Okay. Part of my plan today is I just want to introduce you to the project. So part of the syllabus says the project is assigned in week 5. So I'm going to assign the project in week 5. There's not much we can really do about it yet, but I'm making you aware of this. Okay, is the project here? No, the project isn't here. But I bet you anything, it's in the assignment. Okay. So the project assignment is up on Canvas. And it is like, it's visible, so you can access it. So the idea with the project is to choose, it's really open-ended. So we're going to talk about different kinds of algorithms. We've talked about data structures and the different algorithms that can go with those. So the idea for the project is you choose one or more of the topics that we talked about, and you choose an application of interest, and you combine the two, you show how the algorithm works for the topic, and explain it. If this sounds extremely and overly broad, that's because it is. I want to give you as much leeway to find something cool and apply something that we learn in this class to whatever you've discovered. In terms of what you're going to give me, so you've got, first of all, the thing that's required is you have to write some code of here's the algorithm or some kind of topic. And kind of like the video, having your non-trivial data and processing it. And so having a code repository is mandatory. Other than that, you have to choose a way to explain what you've done. And so that includes, you could write a paper on it. If you want, you could write like in like a academic paper style, like IEEE. I'm happy to provide resources on that. You could do another video, like similar to the data structures video, or you could make like an actual poster board and do it that way. If you choose the video, trifold, or poster, you can submit it to the research conference. And if you do that, then you get 20 points extra credit for going and presenting. Otherwise, you have to present in class and you don't get those points. So I have some ideas here to get you started. Hopefully these are not your ideas. Yeah. So the idea is choose something that you're interested in that you think can be applied to some algorithm, and then choose an algorithm and apply it. I'm happy to set up meetings if you've got nebulous ideas, if you want to talk things through, I'm happy to facilitate that. In terms of where we're going. Week 5, hooray, that's us. It's assigned, so just so that you know about it. You can work in groups, so you can work on it alone. I recommend working on it in a group just because that cuts the work. Group size less than or equal to 4. So choose your group, brainstorm your topic. That's where we're at right now. By the end of week 8, which is just before spring break, and also the week of our midterm planned, you need to set up a meeting with me to discuss your topic. And because I just want to have a conversation with you before you get going on the project, just to make sure that it's within the bounds of something reasonable for the assignment, or if there's anything additional that you need to do. So roughly by just before spring break, your group should set up a meeting with me and talk about it. If you choose to do the research conference and showcase, there's a deadline of April 15th to sign up for that. And then you work on it. I'll have progress reports in the second half of the semester. So week 11 and 13. And then week 15 is submit things and either present at the conference, which I believe is the last Friday of the semester, I think, and or in class. So everyone's going to have a chance to present. It's just, where is it happening? Okay. Any questions at the moment? Yeah. How many people in each group? Less than or equal to 4. With a lower bound of 1. Yeah. Yeah. Thanks for playing the video. I have to look into the research conference, but their website said like a video submission is also acceptable. Yeah. Other questions? Okay. I hope this is fun. I hope you get a chance to go and choose some interesting thing and then apply something we learned to that. That's the goal here. Okay, I'm gonna pause so I can add the attendance. Okay, so that's the project. So now we're going to watch, so we're gonna, okay. So last time I was debating, are we gonna do sorting? Are we gonna not? I've decided to do one day on sorting, and that's today. So the plan is we're going to learn about heaps, because that's something that you should probably know. The heaps, we're gonna, to do this, there's a video by a guy on YouTube who does like really, really good summaries of different sorting algorithms and data structures. And I think it provides a good model for at least like the architect part of your video. So that's why we're gonna watch it. I'll not be recording my screen because it's someone else's video. But yeah, so we're gonna learn about heaps, and then we have an activity. Okay. All right, I think I've got all of that. So let's do heaps. Okay, so before we get started, just to kind of introduce you, heaps are a tree-based structure. So the ones in the video we're going to see are binary trees with some property added onto them. They don't always have to be binary trees. They can have, so binary trees, each parent has 2 children. You can have as many as you think you need. And there's 2 main kinds of heaps. There's a min heap and a max heap. A min heap is where the value of the parents is less than the value of the children. And this is used for priority queue, where when you remove the root, that's like when you're finding the minimum priority. So that's how we tend to implement priority queues. For max heap, it's the opposite. So the value of the parents is going to be greater than the value of the children. So we'll see how this works. Okay, let's go here. And I'll pause recording and we'll watch this. Okay, so I hope that was helpful. I like the way that he does the small examples. Because I think that helps to like to help you understand as just like starting this. The other thing I'll say about heaps are that we store the information as an array, right? We represent it as a tree, but we store it in an array. That's like in the code where it lives. But we store it in a way so that we can say that when we draw it as a tree, it has this property. Yeah, so why is this slide like this? Let's try this again. Yeah, so to insert something into a heap, you will put it like over here, and then it's similar to like the binary search tree where you check is the property still holds, and then if it doesn't, then you have to move it around. And similarly for a heap, what we were always removing in heap sort is you take the root, the very top thing, swap it with the thing at the end of the array, and then you're like, okay, that bit is sorted. Okay, so that's an introduction to a sorting algorithm that maybe you haven't seen before. And so for our sorting spree today, I'm going to have you work in your neighbor groups, decide who's in your group, and you're going to maybe do some Googling and search for a sorting algorithm that's previously unknown to you. So maybe heap sort is new today, so you choose heap sort. Maybe you already knew it, and so maybe you look at something bucket sort or radix sort, or something else. So look up another sorting algorithm that you haven't seen before and try and figure out how are you going to explain it. Come up with a simple example like the video did, and I've got markers so you can kind of go draw it on the board. And then I think maybe depending on how long it takes you, maybe at class goes to 3:10. So maybe 2:30, 2:45. We'll have each group demonstrate, here's how this sorting algorithm works. And then if you're not in class today, I'll have you write something, like just do the explanation thing, but just on a sheet of paper and write, here's how it works, and then turn it in. Sounds good? Cool. Learn something new.